Dear students, in this video we are going to see about the generation of high DC voltages. We have to generate very high voltage DC voltages. The methods available for the generation of high DC voltage, we know very well about that. The basic voltage, DC voltage, in a natural form, we are going to generate AC voltage. Then we have to convert the AC into DC by using rectifier. Half wave and full wave rectifier we know very well, already studied a lot. Then voltage doubler circuits, then voltage multiplier circuits, then electrostatic machine, band graph generators, electrostatic generators. Then we can go for the regulation of DC voltage. In this video we are going to deal about how the generation of high DC voltage can be obtained by using voltage doubler circuits and voltage multiplier circuits. We know very well about the generation of DC by means of AC input. So first consider about the half wave rectifier and the second one is full wave rectifier. The basic input is AC by using high voltage transformer. By connecting the rectifier, that is diode, with respect to the load, we are going to convert the AC into DC. The pulsated DC is by using filters can be improved, that is filters to improve the pulsating DC to pure DC. In the second case, the same transformer, mid connected transformer, is used for the full wave rectifier, or we can use it bridge rectifier for getting AC into DC. So these are the basic circuits, rectifier circuits we are going to use for the conversion of AC into DC. This is actually the input sine wave. We are getting the half wave rectifier with the filter effect, the pulsated DC into almost pure DC. This is a full wave rectifier output with the filter effect. This is the average ripple voltage in the output side of the full wave rectifier. This is similarity of the same. We are going to say that single phase rectifier. The same circuit is repeated here. Then we can go for the basic simple rectifier circuit. Whatever we are giving the voltage to the input side, the output side we are getting less than the actual voltage, input applied voltage. The ultimate aim is to how we are going to increase the output voltage level. That is called a simple voltage doubler circuit. I say the input voltage is 1 volt. We are getting the output of 2 voltage. By connecting the capacitors and combination of diodes. Here C1 is the input capacitor for increasing the voltage level, and C2 is act as a filter. First consider the negative cycle. During the negative cycle, the C1 will be charged through the rectifier R1. Negative cycle, if it is more negative compared to the positive, the R1 rectifier is that is diode is in DC we are using the term is called rectifier. It is actually forward biased. The capacitor will be charged to the Actually, we are applying Vmax input, the maximum voltage of plus Vmax. During the positive half cycle, the upper point is more positive compared with the lower point. The terminal of C1 rises to a voltage of plus 2 Vmax. Already 1 Vmax is there. Then second, the supply voltage is 1 Vmax is there. And the already available stored energy is 1 Vmax. That will be discharged to the R2 as 2 Vmax to the load. Then we can get the value of the load voltage will be, normally we are getting less than the 2 Vmax. Depends upon the time constant of the C2 and the value of RL and the forward charging current. Here this value of C1 and C2 must be the same rating. If the load current is high, then the ripple is also high. This is actual output voltage. I can say 1V is the actual voltage applied input side. We are getting the voltage higher than the input side without changing the input voltage level. We are getting the value of voltage 2V. This is actual output voltage waveform. This is a voltage W equal. Next we are going to use it for the cascade voltage W equal. What is a simple voltage W equal? We are obtaining only 1 volt is applied to the input side. We are getting the maximum of 2 voltage in the output side. I need to increase further. I say if I am applying 1 voltage input side, I need to get more than the 1 volt, not only multiple of 2 volt. That is more than that voltage. I can go for the cascade voltage W equal. But the basic thing is to implement the same by using simple voltage W equal. We are going to see about the cascade voltage W equal. We are going to use the transformers. One transformer is used for the input of the secondary is connected to the next transformer of supplying input. T is nothing but the isolating transformer, whereas T1, T2 and goes on increasing the level. Once the increasing the level, we need to provide the proper clearance. That's why the transformers are arranged in a vertical manner. The parallelly capacitance and rectifier will be added as like in the simple voltage W equal. Now consider here for the first part we are getting the value of 2 voltage. In the second upper part we are getting the value of again 2 volt. The summation of voltage is 4 voltage obtained across the loop. See here we are using the cascade voltage W equal by using huge number of transformers. What is the problem here is we are going to increase the voltage levels. We need to increase the number of transformers. Each stage transformer is required and isolating transformer is also required between the each stage. That way the cost of the system is, that is voltage doubler is increased high. In order to reduce that, we have to go for voltage multiplier circuit. So in simple voltage doubler circuit, we cannot get voltage beyond this 2 voltage. What can I do? I am going to increase the voltage level beyond 2 voltage. I can go for cascade voltage doubler circuit. What is the difficulties in that? If we are going to increase the voltage level, the complexity and cost of the system is increased. Then that's why we got to go for voltage multiplier circuit. Okay, this Cockcroft voltage, Walton voltage multiplier circuit is introduced, multiplying the voltage in order to reduce the complexity as well as the cost and bulkiness. By Cockcroft-Walton introduced this circuit as voltage multiplier circuit. Actually, the first initially started with the voltage multiplier circuit with pulse generator. After that, by using a normal high voltage transformer is used for making a higher voltage level. Here, one single high voltage transformer is used in the input side. There are a huge number of combination of diode rectifiers and capacitors are connected in a vertical manner. We can get huge number of voltage at the output side. So if we are going to consider the bottom stage alone, it consists of two capacitors and two diode across the load. It is called as a simple voltage double circuit. We are going to extend the same for multiple range, the second stage, then third stage, up to n stage. We are going to increase the stage by stage, multiplying the voltage. Then we are getting the voltage across output is added. For each stage, we are getting the output voltage of 2V. Therefore, n stage 2 nt n nt V max, that is the actual output voltage across the load. Okay, for considering the each stage, the operation is similar to the simple voltage double circuit. Say example, I am going to apply the voltage V as the input side. The first stage, the voltage obtained is 2V max. The second stage obtained is 2V max. The total voltage across these two stages 4V max. For considering the third stage, I am getting the output voltage of 2V max. So up to 3 stage, we are getting the value of total output voltage of 6V max. And that means 2 into n into V max is the actual voltage output. N is the number of stages. If it is 4 stage, we are getting the output voltage of 4 into 2 into V max. 8 V max is the actual output. The one constraint is that we cannot increase the number of stages beyond certain limit. We have to consider the optimal stage. Beyond that, we cannot get a proper voltage output as like voltage cascade voltage circuit, voltage double circuits. This is the functionality, the working is similar to the simple cascade voltage double circuit. We are going to multiply the same for the n stage. We can get the output voltage of 2n V max. Okay, this is the way we have to generate a higher voltage by using voltage multiplier circuit. That is especially mentioned that Cockcroft-Walton voltage multiplier circuit is applicable for generation of very high DC voltage by using a single stage input side, by using a single transformer. We have to use it to reduce the complexity of the system as well as the bulkiness of the system. It is a efficient voltage multiplier circuit. I hope this video understood about the how the high voltage will be generated. Hope find you well.